Hi, welcome to part 3 of waves on a string. So we went through pulses and interference and standing waves. We're figuring out how the string length is going to relate to the wavelength of our wave. So remember, V is lambda F. That is wavelength. Alright, so if we have a string with length L, we could have a standing wave pattern that looked like this. And if we just draw this back out here, imagine if we went a little bit farther. Remember, a full wavelength looks like that. So this would be one full wavelength, but we only have half of it. L is equal to lambda over 2, because this would be our full wavelength. We only have half, so half of a wavelength. N here, which is our number of antinodes, is 1. Number of antinodes. This is what we call the fundamental in music, or our first harmonic. So if this were a string that you plucked and it made this waveform, you'd be playing the first harmonic of the string. So now we move on to 2 antinodes. Here you can see L is equal to lambda, right? That's a full wavelength. This is what we call our second harmonic. And then if we go over here, we have 3 nodes. This is our third harmonic. That part is pretty simple. We got 1, 2, 3. And if n is 3, then you just take that number that's your number of harmonics. For L, we have 1 wavelength and then half of a wavelength. So here, L is equal to 3/2 lambda, or 1.5 lambda. So 1.5 wavelengths are what this length is equal to. We have 1, 2, 3, 4. So this would be our fourth harmonic. And L would be equal to 2 lambda. Alright, now let's do a harder one. Alright, let's say this is the wave pattern you're given. We want to know N, our harmonic number, and what L is equal to. Alright, so let's start by counting the antinodes. 3, 4, 5, 6, 7, 8. So N equals 8. That means that our harmonic is going to be the 8th harmonic. And since 8 is 2 times 4, what we can do is we can say that L for 8 is double L for 4. So it's 4 lambda.